Hi, welcome to the video tutorial for the 10th Let's Think secondary science lesson that we've called the Seesaw. What you'll find is all the lessons in Year 7 begin with a cartoon and illustration that is designed to prompt the students to warm them up to the way of thinking that they're going to be challenged to develop during the lesson. So the seesaw illustration here is simply two people on a seesaw. Father and a child, or whoever you like to say they are, and just to get the students to think about the fact that we're dealing with two variables here, length and mass. And the seesaw equipment, which you'll be familiar with as a standards moments activity, is in this one, is here. The important point, because we want them to start thinking about how variables combine. In some of the later lessons we do think about equilibria, where there are 4 variables to manipulate, but here in this activity the students are thinking about ways of getting the beam to balance, but they actually can't move this mass. This stays at hole 2, so you have 400 grams at hole 2. On the opposite side they can change both the distance and the mass to try and find all the ways that make it balance. Because what we're doing here is we're revisiting inverse proportion that the students first met in lesson 9, where it was a very qualitative feel with the tree measuring. So the further up the tree you go, the smaller the diameter. Whereas here we're starting to quantify it. So that can be said in very many ways. There are 2 ways you can do the balancing. You can either use 100 gram masses or 10 gram masses. You have to. The school where I work part-time, we don't have 10 gram masses, so we use the 100 gram masses. But really, it's easier and probably safer to use the 10 gram masses, because all we want the students to do is get a feel for the pattern of the relationship. So the further you go out, as you can see in hole 2, 400 gram balances, the further you go out, the lighter it becomes. And really, this is the tip of the iceberg for the students, because once they start spotting the patterns, how they articulate that starts to open a whole world of mathematical relationships, and how you explore that on the board, writing down what the students say, writing down how they approach it, is very, very interesting. And you need to think and plan carefully how long that will take, because there are several activities to follow this with the students, and some classes will only do this one and quantify the relationship, and you can then respond to that with further questions. Others will go through several of the work cards if you've got the time, if you feel it's appropriate. So more able children will start to articulate the fact that the product has to stay the same. So in this one, it's whole 2 times 400 is 800. The answer's always 800. For less able, it might be the further out the lighter it gets. And then as they hear their peers, they'll start to realise that there's a constant here. Because we are dealing with inverse proportion, y times x equals m. And if you change y, you have to change x to keep m the same. So if you have a look at the first work card, this really has all the instructions the students need, and it's simply a prompt to get them to explore the patterns. And the important thing to mention is that it doesn't really matter what the fixed weight is on the left hand side. It's how, if it's balanced, it's how on the left hand side, it's how you change both of the variables to keep it the same. So what you'll end up with is a thought experiment at the end, where they have to predict where it will balance and then test that to see if it comes true. The second one, which is almost like the second activity if you like, takes them further with the thought experiments, balancing 150 grams. Imagining 400 grams at hole 4 that's balanced. What do you have to do to the other side? What do you have to do if you double the mass on the other side? What do you have to do if the mass on the other side moves in? So you're really getting to think about what is happening on the other side with the unknown variables. And then we move to 3 different scenarios that can be done one after the other. You might pick one, you might give one as a homework. The frying egg example, because there are some missing values to fill in, is probably the easiest to start with. The idea, the hotter the temperature, the less time it takes. There's one where the students have to imagine 2 people on a swing, where in some playgrounds they have these where you hold on and you can balance while you're spinning round, but heavier people need to move further in. And there's another example of children playing with plasticine, where they're pulling it through. So for a fixed mass of plasticine, the outcome at the other end is much, much thinner. In the past, one of the words that I've used with the students to give them a concrete handle on or a concrete label so they can start to process the thinking more clearly is the idea of compensation. And there's two, this is good because it has both a qualitative feel and a quantitative. Because what we're trying to do is sow the seeds of the students using ratio and proportion to solve problems, especially when you get to the harder aspects of science that involve equilibria, where there are 4 variables to deal with. We're trying to prepare them for that now, prepare them for some very difficult thinking. So we're introducing it for some students in a very qualitative way. You know, compensation is an additive relationship. As the water gets colder, you need to add more soap to have the same effect as you would when the water's warmer. But really, we're leaving the door open for the students to think multiplicatively. You know, yx equals m. You know, and in some of the activities, they could actually plot a graph to see how this works very, very nicely. And there are some interesting links that you can make with your maths colleagues to explore how the students process and understand this concept that we're just starting to touch upon with the first lesson in Year 7.